understand if you guys know what goes into it. So if you guys don't understand the individual elements, what's a compound, what's small, what's what it is, a mixture, what's a solution, you guys do not understand compounds, right? So I want to first start with polyatomics that you guys have to know. Now, this changes from professor to professor, but this list is compiled from all of them. So they should have given you a cheat sheet of what you need to know for the test. So go off that, but I'm not missing one. Okay. So I'm going to start with our only positive polyatomic. Let me know what that is. There you go. Ammonium. What is ammonium? You know it's charge? It's a positive one, right? This is ammonium. Not to be confused with ammonia, which is a compound, it's neutral. Okay. An ion just has a charge. That's all an ion is. Okay. So we have ammonium. Okay. Do you want to go to the other ends? Nitrates. Okay. If I'm doing nitrates, how many options do I have? 3. What's my charge? -1, right? This is nitrate. If that is nitrate, what is nitrate? NO2. My charge stays the same. When my suffixes change, all that means is the oxygen number has changed. It doesn't mean my charge has changed. Charge stays the same. Okay. With nitrites. Okay. What about our other 8s? Sulfate. Okay. So 8 or ice just means oxygen. Just means there's oxygen in it. So I know I have to have an oxygen with sulfur, sulfate, right? How many oxygen? There's 4. Okay. 1 more than nitrate. Okay. That's how I usually put them. Sulfate, phosphate, nitrate. This phosphate also has. Okay. What's my charge? 2. -2. Because I'm bigger than nitrate. So I go -2 instead of -1. This is sulfate. Okay. Which means sulfite is 3. Keep the charge. Okay. Ammonium is weird. The reason I remember ammonium is because it is the only positive. Okay. So let's go to our other 8s. Okay. You said phosphate. What's phosphate? 1 more than sulfate. -3. Okay. Nitrate, sulfate, phosphate. -1, -2, -3. Okay. Do you guys care about a phosphite? You guys don't have to memorize phosphites. But can you assume what phosphite is? CO3? -3. Okay. And yes, the negative or the positive does go after the number. I know that sounds weird, but it does. Because it's charged, it's not you're not taking away 3. It's just charged. Okay. So other 8s, we have carbonate. Carbon, so I have to have a C8 because I have an oxygen. How many oxygen? The reason I remember 3 is because if carbon has 4 oxygen, it is neutral. CO4 is neutral, right? Carbon can only have 4 bonds. It's not something you know yet unless you've done Lewis structures. But carbon can only have 4 bonds. If I only have 3 bonds, that means I have a charge, right? I'm not neutral. If I have 4 bonds, I am neutral. Go ahead. Phosphate, or this is carbonate. Okay. Now, these are the ones you need to know, but are a little harder to remember. You guys focus on these guys, and these guys fall the wayside. So hydroxide, right? It's one of those ones that doesn't tell you there's an oxygen in it, right? Hydroxide, except for the ox, right? It doesn't do the 8, it does ox. Hydroxide. I means element. Hydro obviously means break down the names. The names don't make sense, the names don't make sense. That means it's the standard naming or conventional naming. It means you haven't followed the naming rules to name something like a little game. But element, so I only have oxygen and hydrogen, right? One of each. And neither are polyatomic, which they couldn't be, right? Because this is a polyatomic ion. But that helps, right? Just 2 singular elements. Okay. It has a -1 charge. This other one is one that even I forget most of the time. This is bicarbonate. I know it's freaky because bi should be 2. There's no 2 of anything. It's carbonate without free oxygen. Add on hydrogen. That's one of the problem naming. Okay, this is oxalate. I believe it is only lines that needs to know this one, but please do not think it's possible. Can anyone name that one? Or just guess. It's okay, you don't have to get it right. I'm not straight. Is carbon dioxide a polyatomic? No, it is a neutral compound, so it cannot be. This has a weird name, it starts with an O. Oxalate. Another one that doesn't really follow our naming rules, right? because I'm not telling you I have carbon. Oxalates. Okay. But I'm telling you over and over again that it has oxygen. And then this is the last one. This one's my favorite. C2H3O2. What is the name of this one? You guys have to know this one, all of you. It doesn't follow naming rules. A. And it's with an 8, right? Because I got oxygen. Acetate. I remember acetate is weird. I remember the numbers really. I remember 232, and it's organic polyatomic. Organic means it considers all the elements organic. So, but it's not correct. It's also not acid. Hydroxide is not acid, one, because it's not a compound, right? It's polyatomic. But second, hydroxide is actually what makes up bases, not acids. It's the opposite of acid. I didn't expect you to know. Okay. These are the ones I know as a whole you guys have to know. I believe one is the only one that does oxalate. I believe Cosatec does bicarbonate, but everyone does acetate. Anyway. Now these are tricky elements. Tricky elements are elements that don't really look right, that you kind of have to know their names. Okay. I'm going to start with our metals. Okay. What is that? Iron. The Latin name for iron is ferrous. That's why it is Fe, ferrous. Latin name for that. Okay. Cu, copper. Ag, silver. What's gold? Au. I remember Au for gold because gold is now mined in Australia. So gold mines are in Australia. And then I remember that its brother is silver, right? They're right next to each other. They're right on top of each other. Okay. Now we have Hg. It's the only metal that's liquid at room temperature. Mercury, yes. Only metal that's liquid at room temperature. Okay. These ones are kind of like you have to put the two together to mix them up. Okay. So we have Mn and Mg. Which is which? Is which one? Magnesium is Mg. What is up top? It used to be a country. Manganese. The scientists. Okay. These ones are also look like each other, but neither of them go with their names. We have Sn and Sp. Sp is something we do not use almost at all anymore, just because we kind of ran out of our stock of it as a Earth. But Sn we use quite a lot. Sn is 10. I remember that because 10 ends with an N. What's Sp? Let's start with A. No. What's arsenic? As. As is correct. Antimony. All right, now I'm going to our alkali metals, those two over there. So this is the one where I always put together because we have so many B elements, right? We have B, BE, BA, BR. Yeah. One of these is not like the others. One of these is or two of these are non-metals. Okay. What's B? Boron. What's BE? Beryllium. Which is a very pretty metal. Okay. What's BA? Name of a scientist. Barium. Br. Bromine. Bromine. Bromine is in like every compound. Okay, the halogens FCl, Bri, and ATH. It's radioactive. But all four of those, because they have a -1 charge, which means all that they need is one electron to be stable. They are whores. Okay, you'll get with any element as long as it works. Okay, you'll see them in a lot of covalent compounds because they're just looking for things. Okay, now. Okay. Your new nursing student, you need to know that one. Potassium. The one right above it, Na. No. It's salt a compound. Or is salt an element? Yeah, it's salt, NaCl, stable salt. That's all the ones that I highlighted. So magnesium versus manganese. I see people mess these up all the time. Okay. Iron is usually our easiest. I think of the weird ones, remember? Cobalt is CO, copper is Cu. Okay. Okay, who can tell me of the list up here has charges that are not variable? So non-variable, variable would be multiple charges. Non-variable would be a singular charge always. Potassium. You said sodium. Brilliant. Brilliant. Yeah, you're good. 4R, yes. So magnesium, yes, magnesium is not a transition metal. Let me show you. Or no. BA is also up there, right? Because BA is not one metal. Okay. What is the trend of all the things that I've not circled? They're all transition metals. Variable charge. And you cannot read cursive in the nicest way possible. You kind of should look. I learned cursive. I was a nun, by the way. So I kept it going and it's kind of hard to stop. But I am, of course, kidding. I'm ready to get back. Okay, transition metals have variable charge. Where do transition metals start on the periodic table? Give me a group name. So what is the group number that it starts? 3, right? And it goes into that stair step. We have little pickings inside those transition metals that do not have variable charges. Okay. Can anybody tell me where my exceptions are? Zinc, good job. What is its charge? 2 or 1. I know some. Yeah, silver's 1. What's its last third? The third, that's what silver and zinc is. Look at silver and zinc. They both touch the third one. Cadmium. Silver, cadmium, zinc. Those are your 3 that have variable charges right there in that block. Cadmium. Okay, 1, 2, 3. Okay. And you said aluminum. Really? Okay. So, you guys, your periodic tables or the one up here. You have a block right here. Zinc, cadmium, silver. These 3 have non-variable charges. Okay, makes a little L. Okay, little L. A lot of people don't talk about cadmium because we don't use cadmium a lot, but it is one of those 3. Cadmium should have a 3+, but I will check that. Okay. What is aluminum's charge? 3+. Any other ones? In the transition block, right? Everything outside of the transition block do not have a variable charge. Their charge stays the same. Their charge is the same through their families, right? Families are also called groups. Okay? Families have similar characteristics, which means they all have the same charge vertically. Periods are your horizontal. Periods just say I'm increasing proton count as I go. That's all a period is. Periods also have stuff to do with electron orbitals, so they're all in the same electron orbital in their own blocks. Is this helpful? So when it comes to naming, we use all of these things. Right? I like to go over this because you guys can go into that test line. I will also say on your test, unless things have changed drastically, spelling counts. You have to spell the elements correctly, or there's points on. Okay. That sucked for me. I don't have the fine speller, but yeah, spelling counts, yeah. And you're gonna have to just tell them who it is. Yeah, you're not supposed to know which one. I wish I could tell you which ones are gonna be. I can't imagine that would be the transition model, but it might be those 3, silver, cadmium, and zinc, right? Because you're supposed to know where those are. It might be some of your halogens or your diatomics, right? That's one thing I did not say about diatomics. Okay, that's our last little before we name. Diatomic elements. Okay, what is a diatomic? Yes. What does it sound like? Di means 2. Atomic means atom, right? Which is an element. Element, atom. Okay. So, yes, that makes one molecule, right? 2 atoms. They have to be the same atoms, though. They have to be the same element. Okay. Diatomics are just when elements exist by themselves, when they're neutral, not when they're ions, right? Ions is singular. Okay. If I have a singular bromine atom, it'll be Br -1. That's a single bromine atom. But the halogens, and then a little bit over from the halogens, they like to make diatomics when they're alone. So that means if I have a beaker full of bromine, right? My bromine will connect to each other to become neutral. Okay, so that's bromine and another bromine atom. So Br2 as a subscript. Okay, there are 7 of them. Okay, fluorine down to iodine, right? And then fluorine over to carbon, and then hydrogen, which makes 7. There's a literal 7, but there's also 7 elements. Okay, I always start with hydrogen, H2, because that is one you're going to be seeing the most. H2O, right? And then we jump to our 7. Our 7 starts at carbon. C2. Okay, into O2, F2, CO2, Br, and I. There are 2, 3, 5, 6, 7, 8. Every time I have to ask myself carbon is one, but it's never is. I don't know why I'm doing that. In O, Nof, Clubber. If that does anything for you, I just mashed all the elements together. So in to I makes a 7, and then you have hydrogen. Okay, that works. I've never been good at mnemonics. Mnemonics is like assigning words to stuff. I've never been good at it, but that's good. What'd you say? From O-N-O-F-C-L-E-R-I. Good. It's nice. If you guys need a more legible version of that. But also, if you can't remember something like this or any of the other things trip you up, use the periodic table to your advantage. You're given the periodic table, but also the periodic table is made to help you. Okay, the dude who made it, Mendeleev. He was a Russian scientist, and we had these kind of groupings of atoms, or elements, but we had no way to put them together. And so he didn't have as many elements as we do now. We now have like 103 elements or 114 elements, but we didn't have that then. We had about 25. Okay, so he arranged them in a kind of nasty-looking periodic table, in which he grouped all of them vertically by how they behave. Okay, so and then this is by proton count. So use it to your advantage. These guys all act the same, and then you have their brothers next to them. Over here is nonmetals, stair-step metalloids. You want to tell me what a metalloid is? In between, right? It has properties of both metals and nonmetals. Okay, and then we have our nonmetals, right? And then that's divided up into transition, alkali, earth, alkali, all of them. These are diatomics. These do not exist in compounds. Okay, compounds are made of ions, right? 2 ions or multiple ions coming together to make a neutral compound. These are neutral. These exist by themselves. Okay. All right. You guys want to get into negative? I'm gonna do this again. I'm gonna erase this because I want you to memorize this. Okay, so if you've not got it down, take pictures. But it is up to you guys on what type of compound we start with. So make your thinking now. Really, the packet starts with ionics. Ionics? Okay. What is an ionic compound? A metal and a non-metal. So I have positive charge, right? And a negative charge. Right? Metal is positive charge always. Non-metals are negative charge. What do their electrons do? Do they share electrons or do they donate electrons? They donate. Okay. Now I want you to remember that they donate. I have a positive charge here, right? Positive charge means I have less electrons than I have protons. Okay. More electrons you have, more negative you get, right? A neutral atom would have the same number of electrons and protons, right? Negative, positive. My negative has more electrons than it does protons. Okay. Which means this negative gives electrons to my positive. Okay, so that they can be neutral. This is do not share electrons, okay? Which means I cannot make a Lewis structure of an ionic compound, right? Because Lewis structures depend on the sharing of electrons, okay? That's what those bars mean, is that electron free share, okay? So if I'm donating over an electron, right? That's how we do that switch, okay? Let me give you an example. So I have to start with the metal, so shout out a metal. Your favorite metal. I'm the only one with silver, okay? We have Ag. What is silver's charge? Do we know it? Do we know silver's charge? Yes, it's one of our 3. What's silver's charge? +1, okay? What do we want to put it with? Give me a non-metal. Chlorine? What's chlorine's charge? How many electrons does it have to give away to become a noble gas? 1. Sorry, gain. It has to gain electrons, otherwise I give away. Okay? So if I have +1 and -1, I'm still gonna do my crisscross, right? So my end result is that. What is the name of this? Can anyone tell me why I did not put a Roman numeral? Because I know the charge is silver. It is a non-variable charge. Okay, charge does not change, so I don't need to tell you what it is. Okay. Okay. Can someone tell me why I put I? Why is at the end of the day? Anybody have an idea? I said it earlier. If I drop side. Singular atoms, they're just elements. I means element. Okay? Polyatomic, it is just an element. Okay? So I put I. Silver is just the name of silver. Ionic compounds just go by, the names of them are just telling you what's in it. Okay? Because I can figure out the charge of anything that is in an ionic compound, you don't need to tell me how many there are, right? But this one there was one, right? One of each. But if I had something that had two of each, so if I had zinc is plus, what is zinc structure? Plus 2. If I had zinc, right? Zinc 2 plus, and let's say I had chlorine again, right? Minus 1. I should go by that whole, right? If I switch these two, right, as my crisscross, the reason I'm doing that is, of course, to get the ratio to 1, right? Because zinc has a 2 plus and chlorine has a 1 minus, I want my charges to be equal, but opposite, right? I want 2 plus over here and I want 2 minus over here, right? To do that, I need 2 chlorines. So zinc, Cl2, right? What is the name of this one? Zinc chloride. Go on. You're good. You have a question? Oh, no, sorry. You're just nodding. Okay. So yeah, exactly. So there's an I here. Do you see how there's 2 of these, and I'm still saying I? It's because it's still just an element, right? I don't need to tell you how many there are of each element in my ionic compound. Okay, I just need to figure out charge, right? To make my formula. But in a covalent compound, right? Yes, but I'll do more examples later, of course. But a covalent compound is what? What is it made out of? Non-metal. So I have a negative and a negative, right? If I have a negative ion and another negative ion, can I ever be equal? Opposite. Can I ever cancel each other out? No, because I could give you a million negatives and then give you another billion over here. It would still just be 2 million negatives, right? It doesn't make a neutral atom. So these guys share electrons. They share, right, to keep together. Because they both have extra electrons go around, so they share. But these guys, I don't care what the charge is because my charge is never going to cancel out. So what I want to know is how many there are. Okay? So if I said, what is the name? Because I need to know how many there are. So how do I tell you how many there are? The prefixes, okay? Boron has how many? How many borons are there? 1. So I don't need to say anything, right? Because it comes first. So I'm just saying boron. How many fluorine do I have? What's 4? Tetra. Tetra. Fluoride. Fluoride, the U comes first, not like flour. Okay. Still, we have the I because it is an element. This, how many? This technically says how many, right? Yes. Tetraboron. The only reason I did not put a prefix here is because this is 1. We never say mono to start with. Okay. If the second one is also 1, like if it's just BF, it's boron, mono, fluoride. Okay. As long as it's not 1. Okay. I'm going to, so there is another. So when we get oxygen in the mix, right, which is a lot of compounds, right? Let's say I have NO. This does not exist, by the way. So if I name this one, okay, what's the name of this one? Dinitrogen. The first one always keeps its elemental name, nitrogen. Okay, what's this one? Hexa. X oxide. The reason I did not put an A is because I'm not going to put 2 vowels next to each other. Oxygen is pretty much the only one you have to worry about with that because it's the only vowel. Right, it's the only vowel there. So I worry about it can't be hexa. Oxide just sounds weird. I'm literally telling you it's just because it sounds weird. There is literally no other reason I can think of other than you. Okay. I have a literature degree too. I will say it sounds you, but like, okay. But yes, you get rid of whatever vowel belongs to the prefix to keep oxide. Vowels are A-E-I-O-U, sometimes Y. No one ever tells you Y and sometimes Y. Y is pronounced. Y is sometimes Y.
Yeah.
Good vowel. Okay. So this is my name. Not my name. Okay. So let's say I had this one. It's a compound that could exist. No, why can't it exist? Two positives. Do I have any elements to go around or any electrons to go around? No, so I cannot make a connection. Okay. When I have extra electrons, I can share them. If I have one who has extra electrons, I can give them away. But if I have no electrons to share, they just kind of butt up against each other. They're not going to make a compound. Metals and metals do not make compounds. Okay. We can mix metals together, which makes an alloy. Okay. An alloy is just melting two metals together, making something out of it. That's it. An alloy is not a compound. It is a mixture. But if I have a solution, which is that's how we say solution, by the way. I have a solution. I have a solution of magnesium chloride and water. It's the only type of word problem we get on a test when it comes to meaning. This looks pretty. But I have a solution. Okay. What makes up a solution? No, you said that last time too. What makes up a solution? What are the two parts of a solution? They both start with S. What else? Solute and solvent. Okay. Can anyone tell me what a solvent is? Or what a solution or what a solute is? Solutes are dissolved by solvents, you could say, right? Solutes are these little mass. And I put that parentheses so that's not quite the right word. It's a little part of the solution, the smallest part of the solution, right? Solvent is the largest. Solvents dissolve solutes. Okay, if you ever use the word dissolve. We also use the word dissociate. Okay, if I dissociate a compound or I dissociate a solute, I'm breaking it up into its ions. Okay, so if I dissociate magnesium chloride, right, because H2O is our solvent, right? Is there a solvent? Okay, so this has to be our solute, right? So if I dissociate magnesium chloride, what do I get? What are the ions that are present in magnesium chloride? Magnesium and chloride. What are their charges? Don't look at the periodic table. Don't look at the periodic table. Look at my formula. 2 and 1, right? That 2 has to belong to magnesium, right? We're doing reverse flipping. 2 plus. Yes, you can look at the periodic table and know that. But there are going to be times where you get like a polyatomic ion and you're not going to remember its charge. You're just not going to. That just happens. There's a lot to memorize. And you're going to get there, you're going to go, oh, I don't know. But if you have a formula, you can tell me the charge of one of them, right? You can tell me the charge of that polyatomic because the other one has to be a known charge, usually, right? Or you can just try to figure it out, right? So I want you guys to be able to look at a formula and tell me its ions without looking at a periodic table first. If I have a bunch of chlorine ions swimming, will they make a diatomic? Will they make a molecule? Yes. These guys will make Cl2. Okay. Well, magnesium. No, it just has to connect to something else. It's going to break apart Cl2 to make MgCl, right? The reason I did not break up water, one, it's our solvent. Our solvent does not break up. But two, water is something that is a universal solvent. Okay, that means a bunch of our compounds can be dissolved with water. Okay, the reason that water is the most important thing on Earth because nothing exists without it. Okay, because we need water to break up compounds so that ions are available to us. Okay, if you've ever heard of the word electrolyte, an electrolyte is just something that can be broken apart by water so that our body can use ions. Okay, so like salt is an electrolyte. Water breaks up salt into sodium ions and chlorine ions. Those two ions go into our cells and they do a bunch of processes. You ever heard of the sodium chute or the sodium passageway? Sodium, it was a long time. But all of these things are used by our bodies. That's called an electrolyte. That'll come at the end of the semester. But it may be an extra credit question. I don't know the extra credit questions, but it has been before. That's what electrolyte is. And I would like you guys to be, informed about your own bodies' lives. Okay. So when it comes to these, what kind of compound is this? This This is an ionic compound, right? So I have positive and negative. What I want you to do every time you see a compound is assign charges. Whether the charges are correct or not, it's not what I care about. What I care is you got positive and negative, right? So I'm going to give you a couple compounds. We're going to assign those. The first thing we're going to do is we're going to assign charges. Let's look at this guy, right? Hydrogen, what's the charge? 1. Don't let that 2 freak you out, okay? This 4 belongs to sulfate, okay? It cannot be taken away from sulfate. Sulfate is a ionic, or sorry, a polyatomic compound, right? It is a bunch of things put together. We cannot break that up, okay? So I have +1 is hydrogen's normal, right? According to the periodic table. What is sulfate's charge? 2 minus, okay? What kind of compound is this? Ionic. Does that have a plus and minus? What's its name? Good call. Okay. What he has just done is he has realized that this is an acid. Is it also ionic? Yes, but we have to name it like an acid. The reason we have to name it like an acid is because hydrate comes first. Okay. We have named this as a ternary acid. Okay. Ternary acids are acids with polyatomic. If I have a binary acid, that means I only have elements, no polyatomics, no polyatomic. So if I have something with polyatomic, I do not put hydro in front. That's just binary acids. Okay. So just elements. So no hydro. And then we've decided that this is sulfate. 8 at the end, which means ig. I ate something, it was eggy, right? That's where we get the ig from. We have stated the name of the polyatomic, which is sulfate, right? But we've changed 8 to ig. Add acid. That's ternary acids. Okay. But they behave like ionic compounds because that's what they are. Positive and negative charges. The reason they are different is not because technically the H in the front, because definitions of acids are kind of loosey depending on who you ask. And by who you ask, I don't mean professor, I mean huge monumental scientists, right? So we have Lewis acids, we have Arrhenius acids, we have a bunch of different kinds. So with these guys, we put them in front because they're positive, right? But also they behave like acids in a certain way, which is why we name them acids. Don't worry about that yet. Okay? Worry about that at the end of the session. Okay. This guy. What are our charge for sodium? Plus or minus? Positive 1. If I have a positive charge, that means it's what kind of compound? Ionic. It has to be ionic, right? Covalent compounds do not have positives. It has to be ionic. All acids are ionic, not all ionics are acids. Okay. So this is ionic. So what is this polyatomic? Hydroxide. What's its charge? Yes. Look at the formula that I've given. We know sodium is +1, right? So that one goes over here. We only have 1 sodium, which means what's my charge for hydroxide? If that one has to go over here, right? We have 1 hydroxide. That means that number has to go over here. How many sodiums do I have? In this formula. This is given, this is balanced. 1, which means that has to be a -1, right? 1-to-1 ratio. Okay. So without even knowing hydroxide's charge, without even memorizing, I can know what it is. That's what I was talking about earlier. Okay. If I have only 1 hydroxide and I have 1 sodium, that means their charges have to be the same. I know sodium's charge, i.e., I know hydroxide. Okay. So let's name it. Tell me what's in it. Okay. What about this guy? It's ionic. Why? Can you tell me what Nichols charges? Yes. What is it? It's 2. How do you know it's 2? Because I know chlorine charge, right? Chlorine charge is always -1. If I need 2 of them to match Nichols charge, that means it has to be 2+, right? Okay. So this is ionic, right? We need parentheses because this is a transition metal. Okay. What's the charge of nickel? 2. How do we end? 4. We're on that subject. And I have to go down. How do I know? 2 negatives, so I need to know their charge, other than the fact that they're negative. No, they're never gonna go away, right? They're never gonna cancel each other out. So I need to do what to name them? Count them, okay? What's our prefix for 2? Di. And if you notice, I'm doing these in lowercase letters. That's how you're supposed to do them. Don't give a proper elements are not proper now. Okay. Di what? Nitrogen. Like don't use the suffix. First one. What's 5? Penta. It's a penta. Pent oxide. Good call. Pent oxide. Get rid of that last vowel. Okay. Our next one. Everything how to use Roman numerals, not just in naming, but like how to make your own Roman numeral. Like if I give you the number 4, did you just memorize what Roman numerals that is, or do you know how to use Roman numerals? I'm just gonna go for it. Okay. So we always go to the base, biggest base we have, which is 5 for all of our charges. It's 5. Okay. 5 is B. If I go before it, I'm subtracting. If I go after the 5, I'm adding. Okay. 4 is 1 less than 5, so I put my I here. That's what you. I looked at the 5th grade, but nobody told me when I was in chemistry. So I assuming some people know you guys just memorizing everything, which is fine. But I don't even remember how to do it. Okay. Let's start last one. Cyanide. Cyanide is not an element, by the way. Arsenic is an element, but cyanide is not. Maybe that's cyanide probably something. Is it Fe? Do we do parentheses and formulas? Oh, you're doing parentheses. I see. Okay, go on. Good job. Because this 3 is iron charge. It's the metal charge. So this has a 3 plus. What can you grasp by this formula that cyanide's charges? -1. Right? Because I need 3 of them. Now, it is clear your turn. What you would like to do next. You can do practice, you can do fluid structures. I need to go over electron configuration with you. Some of you guys don't have to have this. You also have the choice to leave. I don't care. We need to let it.